Hello everyone, my name is Dipesh and today I'll be giving you a demonstration on Apache Lucene. Apache Lucene is a high-performance, full-featured text search engine written entirely in Java. It is a technology that is suitable with nearly any application which requires full text search. It is an open source project and hence it is available for free download. So without further ado, let's get started with the demonstration. Lucene first application. This is my Lucene Java project. In this project, I have added the Lucene library at the build path. So in the Java build path in the libraries, you can see that I have imported this Lucene library, uh, Lucene jar version 3.6.2, which is at my in my C drive. This jar can be found very easily on the internet, and it's need to be imported before beginning with the Lucene application. So once the jar has been added, we can uh, we can execute our Lucene application. Okay, so let me give you a walkthrough of the code. So let's begin with the Lucene constants class file. So Lucene constants class file contains all the constants that we'll be using across the application. Here we have defined some string constants which contains basically the name of the index that we'll be creating. Next we have the text file filter .java class file. This class file implements a file filter class which provides a accept method. Here in this method we have this expression which allows us to select a file in a given path, convert the file to lowercase, and then select the file with the .txt extension. So basically, it allows us to select files with .txt extensions. Next, we have the indexer.java file. So the indexer class is used for in converting all the raw data to indexes, which can be later on used by the Lucene search libraries to search a particular uh, term given by the user. So here we are creating an index writer object. Index writer is a core component used for creating and updating the indexes for the Lucene applications. So in this we have a indexer constructor wherein we are defining an directory. In here we are passing our index directory path, which basically points to the location where we'll be storing all our indexes. We are also initializing our writer object with the index directory, the standard analyzer used for analyzing the index. Here we are also defining its version, which is 3.6. We are also defining the maximum field length, which is unlimited. Okay, so next let's have a look at the create index function. This is the base function which calls all of the functions present in this class. So we'll first have a look at this. So in this we have the um, we are so in this we are getting a file array using the list files function. Here we are passing the data directory path. This data directory path points to the location where we are having all our documents. So next we'll iterate through all the files. We'll perform a filter. We'll check if the file is not a directory, the file is not hidden, the file exists, and file is readable. We also use the text file filter which we created to check to make sure that the file is a text file. And if all these criteria are met, then we call the index file function. Let's have a look at the index file function. So the index file function accepts the file. It prints out that it is indexing, and that prints the path of the file. Next, it calls the get document function. So here the get document function. The get document function basically segregates different fields from the document, like the content field, file name field, and file path field. Then we create index using the field object. So we create an index on all of these fields. Here we are passing the field the index name, which is the constant defined in the Lucene constant.java file. So we create index for all field contents, field name, and field and the file path. Next, we add all these indexes to the document and return it. In the index file, then these documents are added to the writer. So the writer is basically writing the indexes uh, to the Lucene application, and in the end, the writer returns the number of documents that were added. So that's for the indexer the .java class. Next, let's have a look at the searcher. So the searcher is responsible for searching the user and the query entered by the user across all the indexes. So the searcher makes use of three main classes, which is index searcher, query parser, and query. So the index searcher is the core component used for searching for a query, which is a term entered by the user across all the indexes created used after the indexing process. Next is a query parser. So the query parser is used for passing the query entered by the user and converting it into a Lucene understandable format. So query is nothing but the any kind of input by the user, which has to be searched across the index. Okay, so this here we have a searcher constructor, which is basically initializing the directory, index directory, which points to the folder where we have the index created. Then the index searcher is initialized with the index directory. And next, we are initializing the query parser. Herein, we are passing the index that we want to uh, look at. So, which is the contents. Will be only looking at the contents index. Next, the standard analyzer with its version. Now let's have a look at the search function. So the search function returns the top docs object. The top docs points to the top n results which match the search criteria. Herein we are using the query parser to create a query object. Here we are passing the search query, which is a string. Next we use the query object to search using the index searcher object, and here we are passing the maximum search, which is 10 for this application as defined in the Lucene constants. This returns the top docs objects. Next, we have a get document. Get document function basically returns the document for the past score doc. Finally, this is our Lucene tester application. Herein, we are defining the index directory, the data directory. We are creating an indexer object, a searcher object. So the testing application basically tests the capability of the indexer and the searcher. So here we have created a tester object, and we'll be using this tester object to create index. We are calling a create index function. So the create index calls the indexer, passes it the index directory, and then the indexer calls the create index function to create the indexes. We are storing the start and end time, and then we are deducting these two to find the time taken to create the index. Then we are using the then we are using the search function to search for a query, which is Ramesh. So the tester calls the search function. Here again we are spawning the searcher object. The searcher object uses search function to for querying the indexes, and this returns the top documents, which is the top and results for the match criteria. So we are here again we are storing the start time and end time and deducting these two to find the total time taken for the search. And then the top document has a list of score documents, which is basically all the score for each document that matches the criteria. Then we can iterate through these scores and get up and then use a get document function to get the document for that particular score and then print it. So now let's try and execute this application. So here we have used we are querying for Ramesh. Let's execute this. Okay, so here you can see that this all the 11 files are being indexed. So 11 files have been indexed in 91 millisecond. Then by after querying, we found two documents in 26 milliseconds, and this is the location of the two documents. So let's have a look at the documents. So here we found the document data in 11 and 1. So in the record 11 file, we can see Ramesh, and in the record 1 file, yeah, okay. Here also we can find the image. So that's it for this demonstration. Thank you very much.